Good morning, everyone. Thanks for being here today, and thank you. Well, I want to thank Anna and all the committee for inviting me today here to talk a little bit about my work in the past years. So we are going to talk about bats, insects, dries, pest management, and how to connect us as conservationists with farmers, which is not an easy task. So for those who doesn't know me, I work in the Natural Science Museum of Granollers, where I became involved in some research in 2005. And since then, I've been collaborating in quite many projects on bat conservation, but I'm really glad to be speaking about my first project in Granollers, even 15 years after that happened, which is an amazing thing because after more than a decade, the results are still valid and are still quite new to be able to present here today, for example. So I've prepared a presentation, a talk, which is quite long, but it's basically a short story about several projects that have been shaping my professional career over the last 15 years. And they are all connected to farmers and how we can use scientific data to promote bat conservation. And we all know that bats consume insects, mostly small insects. They are very avid predators of flying lepidopteras, flying moths. And bats are maybe one of the best heroes in terms of pest control because of two reasons. One of the reasons is that they are very opportunistic. They don't have very narrow diet compositions. They basically feed on everything that flies at night and have this size, like from few millimeters to few centimeters. If it flies and it's an insect, they can eat it most of the time. It's true that there are some species that are very specialist in terms of prey, but most of them, they eat a lot, just whatever it is. And the second thing is that in summer, when agricultural lands are full of crops, fruits, flowers, and they are most of the pest species damaging the products for the farmers, is the exact same period where bats are reproducing. And then that means that females are consuming much more than the rest of the year. They are consuming hundreds and thousands of insects, specifically during the exact same time that the pests are in the worst stage for farmers. So this overlap between huge pressure on hunting and huge impact on crops, that makes them the best animals to be used in integrated pest management. These are the two reasons. And this is something that is not really new. It's not something that I came out with this fantastic idea today and I'm saying, oh, bats are the perfect animals to control pests. This is so old that even Pliny the Elder, in 1 century after Christ, he already wrote that in his book, Historis Naturalis. He said we have to thank bats for feeding on mosquitoes. That's something that we knew for centuries. The thing is, how are we using this information today to improve bat conservation amongst natural biological nature conservation? So we have to use it. And 1 week ago, I just find this paper, which I found very interesting, is why facts don't change minds. This is something that anthropologists wrote, and we as scientists, we should take care, I think, more usually during our research. So we are quite biased on the fact that we need scientific facts and proofs to be able to conserve. And the truth is that we are a very tiny percentage of population that we comprehend and we understand the facts. But most of the population act and change their perceptions and their actions according to much more complex environments and psychologically diverse feelings and perceptions. So this is something that we can use. Ecosystem services is a word that you will find so many times in this presentation today, and has had a wide discussion, and it's quite controversial because many people defend it as a good way to improve conservation, and many people say that it's not the best way to promote conservation. So basically, my talk today is to present what I've been feeling for the last years and what's my feeling about using ecosystem services to promote conservation. One tiny example. I don't know if you have heard about the story of the Great Sparrow Campaign in China. basically there was this crisis time and a crazy emperor that he wanted to solve the hunger that was suffering people in China. And one of the things that they thought is that the sparrows were consuming the grain, and that was the cause of the hunger. So basically they say, okay, let's kill all the sparrows, and then we will have food again. As easy as that, plain and simple. So they basically spend days and days and days hunting sparrows, millions, billions of sparrows in China, which is not a small country, and they kill almost them all. So they basically kill them by making noises until they get extenuated and they just fall dead on the floor, or they hunt them, or they trap them. They use so many things. The problem is when the sparrows disappeared, there was a huge pest infecting the crops because sparrows were consuming grains and also insects. And that was a complete disaster. So they had to import sparrows from nearby countries to bring them back in China. There's something, an example of that we need to think about how we use nature to keep our production levels on a way that people can survive and the ecosystems don't suffer too much, which is not easy. These are 3 examples from China, Mauritius Islands, and USA, in which we use, as farmers, some species to control pests in a more natural way than using pesticides or using chemicals or using other alternatives that are not the most respectful for nature. Some ants killing invertebrates. Here we have some passerines, and in the USA, the ladybugs. But these are only 3 examples. There are multiple of them. And then going back to the topic, because I like to talk about bats. Bats have been involved in agricultural lands and in conservation initiatives broadly. This is one of the most famous campaigns led by Dr. Rodrigo Medellin from Mexico. Basically, what they promote here is that the bats are the only species pollinating agaves, a species of cactus that are the ones used to produce tequila. And it's like a very strict interaction between bats and agaves. And if there are no bats, basically there's no agaves, so there's no tequila. That's the clear short message. And this has been quite impactful in terms of conservation. It has been spreading from Mexico to US and even to other South American countries. Even Bat Conservation International are now very obstinate of using them to promote conservation. But there are many other examples that I like to highlight. Some colleagues from Mexico, Veronica, Constant, they demonstrated that the pitayas fruit are sweeter when they are pollinated by bats, and they are bigger and more rich in terms of nutrients than otherwise. And durian is a fruit from Southeast Asia. It's the national fruit. They use it as a country symbol, as a flag for tourism, even for consuming them. Local people love durian. I don't know if you have ever tried. It's very peculiar. It's really strong smell, really strong flavor, and either you love it or you hate it. I kind of hate it, but I like the story. And again, bats are the only ones pollinating the fruit for durian, so no bats, no durian. Clear message. This is a study that took place in the US by Boyles and colleagues. That is like one of, by far, my favorite studies. They created this huge structure of nets hanging around cornfields, like a mesh net, okay? And they recreated a world without bats inside. So their question is, what's going to happen with our cornfields if there were no bats in the field, if we exterminated all the bats? So they basically exclude the bats from this area, and they studied how the production and the harvest changed over the time. And the results were amazing. So basically, in few, this is days after the crop, during the crop growth, and they triplicate the effects of the pests in the cornfields, just because they excluded bats, okay? And they open it and they close them during the day to avoid the bias with birds. In case some of you are wondering, because I know there's some bird people here, they open them for the birds to go in freely, and then they close it at night during almost 1 year. Crazy. Similar studies in Chile, some colleagues as well, Ana Rodriguez did more or less the same in grape fields with, grape wine. And again, they find very similar results. So the effects, like the damage caused by insects were like herbivory was 3 times more. In rice, what happened? In Thailand, they decided to do something similar, but they basically played with numbers. They modeled the amount of bats that they had, and they did some extrapolations and calculations to calculate how much rice they were saving because of bats. And they came up with the idea that 26,000 people a year were fed by bats. So the gain in terms of food was the equivalent of 26,000 people. I have to say that this is mathematically speaking, it's some modeling results. It's not something that they don't put cages to exclude bats. They just play with numbers, it's good. I'm not criticizing it. And why I'm so interested on rice. So today I'm going to talk about rice a lot. Rice production, globally speaking, it's crazy. It's a lot. It's tons and tons of rice being grown specifically in Southeast Asia. But it's one of the main food staples for many people, many local communities. And it's what basically fed most of the people. So here we are used to a very diverse Mediterranean diet. But in many other countries, like many, rice is like the principal food staple for them all. And in terms of growing, you can see that's very, very similar. Southeast Asia, but also Madagascar and some of the West countries in Africa. Rice is something that, for me, it deserves attention. And now I make now a jump towards what I was talking before. My first project in the Natural Science Museum of Groningen was specifically about bats and rice. So going back to the study. That's the story I'm going to talk about. It started in 2005 when I started my bachelor here, and I got involved in the Natural Science Museum, okay? The thing is, when I arrived, there was a project that already started before in the Ebro Delta. There were many bat boxes being installed because of one of these pan-European projects funded by the European Union, not by these people, but for others. They installed so many bat boxes, but they didn't pay that much attention. The bat boxes were there, kind of abandoned, and that's it. The thing is that over the time, the bat boxes get occupied, and because the people from the museum were the experts, they were contacted, and they were asked to study what was the role of these bats in terms of pest control, because the farmers had some hard feelings about the bats, okay? So these are the two main responsibles, Xavi and Carlos. And the Ebro Delta have been like an experimental station for us. We've been working quite many times. Probably most of you know that, but the Ebro Delta has very tiny natural wetlands in the coast. But other than that, most of the area is basically rice paddies, extensive rice paddies, either dry or full of water, covered by water, depending on the season. But this is mainly an extensive rice crop for tens of kilometers. The problems that the farmers are facing, pedicularia, like fungi, they are also facing some climatic events, Gloria, for example, rats, insects, and amongst them all, there is this extremely interesting insect, which is a Lepidoptera chilosuppressalis. This is one of the worst pests in the world in terms of rice. It's called rice borer because it grows from the inside the stem. When they grow, they start feeding on the plant inside. They kill the plant from the very bottom, and then the plants basically die or get dry completely. And this is one of the most impactful pests worldwide speaking. Getting back to the bats, we got these bat boxes that were not ours, but they were full of bats. There was a substantially success in terms of occupation, like 95% of the bats were occupied, and not by one individual, but by colonies, like colonies of some tens of animals. We got almost 3,000 individuals in few hectares, which is a huge density of animals. I would say that it's one of the biggest reported in Europe in terms of bat boxes stations. And that turns out like a very nice study because we had the worst pest and the boxes full of animals. That's excellent scenario. That's more or less the characters of the story, and we start playing with this. And as you can see here, it started in 1999, so long before I started. And the gray bars shows the increase of animals in the bat boxes up until this moment in which the bat boxes were full and no bats had more space to grow. So it's just the top limit of the occupancy. And at the same time, this infested rice stem just decreased dramatically, like in inverse relationship. That was quite clear for us. That was a very clear message, but we needed to prove it. So basically, we collected a lot of feces from the bat boxes, and well, using basic genetics, we detected the prey in, I would say, more than 50% of the feces in some periods. So during the highest peak of the insect, 50% of the feces had the detections of the Chilops sublesalis. And then we complemented the study with acoustics. That's a very old model. It looks like a radio, but it's really, really old. And we basically create some transects to understand how bats were moving on the area. And the thing is that we detected when there was no insect, bats were moving all around, across all delta, all the regions. But then when we had the insects, and we control also the insects because we captured them with pheromones, where there was more chilo, significantly more bats, basically suggesting that bats were moving, trying to follow the areas where more insects were flying. And this is something that it's quite relevant because at that time, pesticides were used with planes and helicopters massively. At that time, now it's conceptually like impossible. But at that time, people were using airplanes to throw pesticides all over. And because of that, the place where the bat boxes were installed, they had to stop because there was no pest anymore. So at some point in the whole delta, these planes were also throwing pesticides everywhere except in our biological station. So basically, because of the bat boxes, they had to stop because the levels were not too high. And this is something very important as well. The insect has 3 generations. So it's a cycle of 3 generations, reproductively speaking. There's one very tiny generation at the beginning, and then these 2 big. This one, it's not relevant for us because it's after the harvest. So there's no rice anymore. So that's not really relevant. But these 2 peaks, this is the more damaging. And we found out that if we can control insects at the very beginning, then the second one is not hard enough to use pesticides. Interesting numbers. We also did some calculations. I don't want you to read all these numbers, but I only want to focus on this. I don't know if you can read them, but this is the needed number of bats per hectare to prevent aerial treatment. Of course, farmers have like thresholds to use pesticides. If they don't have more than X numbers of pest individuals, they don't need to use aerial treatment. So it's about 10 individuals per hectare. That's one bat box full. And then needed number of bats per hectare to control pest levels is about 50. So if you have enough bat boxes to have 50 bats flying around, that should be enough. That's numbers, okay? That's not like, I don't want to say that's applicable to every place in the world. It's just, that's what we found in the Ebro Delta. And this is one of the outputs of the project, which I'm very proud of as well. That's an animation video, very short. I want to pass it to you. It's about 1 minute. And it's basically explaining the results and what we use to convince farmers. That's the English version, but we have obviously the Catalan and Spanish.
Bats in Africa. What do they have in common? In the year 2000, the Ebro Delta National Park placed 70 bat boxes around rice paddies. In 2001, 200 bats were found in the boxes. And in 2006, 3,500. Meanwhile, the population of rice borer moths, an important pest, began to fall, and much of the spraying of the paddies with pesticides, I then carried out using light aircraft, became unnecessary. Farmers thought there could be a connection between the rise of bats and the fall of moths, so we began to study it. After a few years, we published the results. Quantifying the service bats provide to the producers with densities of around 40 bats per hectare, there is no need to use pesticides to control the rice borer moth. And this is not an isolated example. In 2014, an insightful research was published. In Thailand alone, by preventing the loss of crops, bats guarantee yearly food supply for 26,000 people. In 2011, the prestigious journal Science highlighted the economic importance of bats. If bats disappeared from the United States, it would cost $23 billion a year in pest control. Preserving biodiversity in agricultural areas is a sustainable solution to the serious environmental threats we face globally. We are beginning to understand how bats benefit us, and we still have a lot to learn. At EcoBat, we conduct applied research that can be exported to other regions. This way, we promote the use of natural biodiversity as a pest control method. By joining our project, you will help us understand the role played by bats in controlling pests in your crops. Join the project.
Okay, so obviously this is a simplification. Sorry, this is a simplification. But the thing is that I want to highlight is I've been going to the Ebro Delta once in a while for many years, and I found a dramatic change of perceptions with farmers. So when I went there at the beginning, they treat bats like pests, basically. They didn't want to know anything. And now every time I go, it's like, oh, do you have bat boxes for me? I want more bats in my home. You know, and that's like a common change. And I would say in all the Delta, because I'm moving all the time from many places. And I found crazy situations like having a restaurant with these, you know, these clothes on the roof for the sun, full of bats, like pooing on the place. And the owners say, no, I'm so glad that bats are here. They're helping us to control mosquitoes. And that was unimaginable in 2005, completely. Well, anyway, this is side results, unexpected results. So because of these bat boxes, we also find the first report of the stable community of these migratory bat species in Catalonia. And it's the southernmost distribution of the species worldwide. And that was also because of the bat boxes. And this is a clear example of how people in the Ebro Delta got their mind changing. So they basically decide to build like a huge hotel for a capacity of 20,000 bats in the middle of La Estancada because they love bats. And this is huge. I don't know if you realize, but one person is like that. You know, it's huge. It doesn't have 20,000 bats inside, but have few thousands of animals, and they love it. They love it. It's like an attraction for the park, and you can go and visit. Okay, next step on the project after 5 years, we decided to play with chaff. I don't know if you have ever heard the word chaff. Chaff is in the rice, you know, when there's the grain, there's 2 leaves protecting the grain that they are dry, and they usually farmers just throw them away. So we start playing with this, and we built these bat boxes made with a component of fiber and chaff. So it's kind of cement that is biologically sustainable because we use residuals from the fields. And it's a very nice story. It's like a cycle because the farmers use their residuals to build bat boxes, to install them, and then having bats and help them to produce more rice with less pesticides. And it's like a very nice story of friendship. The thing is, in terms of bats, if we compare that with birds, we don't know that much. So with birds, you go to Oryx and you find the bird box for Raspinel, Parus. You have like 10 different bird nests models for birds, and you know that they are going to be used supposedly by these species. But with bats, we got bat boxes, you know, cubes and cylinders, and you can install them, but you have no idea which species is going to use it, why, where, and when. So sometimes I've been told, no, this is like for hibernation, and I found bats hibernating here. And this is for forest bats, and then I got the most urban bats inside. So we have no information at all. And then that's a nice opportunity for us to start playing. And we built white bat boxes with basically nobody built before, and we use this material that it's lighter than that, it's same waterproof, it's very good isolation. So for isolation, And apparently bats in the Ebro Delta, they like them. This is a close-up for the chaff. It's very dry and there is tons of tons being thrown every year. And then we tested the temperatures. In the Ebro Delta, we reported massive deaths of bats in bat boxes because of overheating events. And that's something that is going to happen more and more due to the climate change. So basically we tested the temperatures and the isolation capacity of the bat boxes. And we found out that the white bat boxes, which is these, and these, had one of the best values to prevent these massive deaths. Of course, if you are going to the Pyrenees, do not use the white ones. But if you are in hot areas and warm weather, that's something that can be used. That's the cycle that I was speaking. The farmers just got lots of chaff and they can use it to bring the bat box, then having birds and control the pests. Very short study. That was a master project by Garazzi, and things continued. The thing is, I met by some anecdotal situations. I met a professor in Finland that was interested on our project in the Ebro Delta, and she was working in Madagascar. So basically we started a discussion and she said like, oh, that would be nice to export all this experience and all these projects that you have in Spain to Madagascar, because in Spain, okay, you have rice, but it's not your main food staple. But for Madagascar, Madagascar is the first rice grower in terms of proportion and area in the world. People eat rice every day, and all the island is covered by rice paddies. So why not bring that to Madagascar? And I say, okay, bring me to Madagascar, and I'm going. That's Mar. If you don't know her, I recommend you to check her projects, which are amazing all over the world, in a lab called Global Change and Conservation. And this is the situation in Madagascar. This was the forest in 1950s, and over the last decades, they have lost a lot, like a lot. The loss of forest is dramatic. This is even 2005, and now we are 2023. So basically, there's no forest left in Madagascar. We only have forest in the natural parks. All the rest is just rice. Okay, and it's a dramatic change. So basically, we went there and we focused our study here because of logistical facilities. And we basically sampled bats, pests, and feces in all these villages. Just for you to understand, this is the forest, this is the natural park, everything else is rice. Okay, and that was James' thesis. We found like 21 bat colonies with thousands of animals, mostly molluscid species. Okay, molluscid bats are these high-flying species, excellent for consuming the pests because they can fly over the rice paddies and they are killing machines for pests. We sampled the villages, local villages, using traditional methods, mist nets, dyed hand nets, hard traps. These are the main characters of the story. These are tiny molluscids. We're used in Europe. Our only molluscid here is like so huge, but they're also small molluscids like this, Mormopterus. And we tried to locate all the colonies. So we visit, for example, this was a library, public library, and they had thousands of animals in the roof, thousands. The police office, private houses, etc., etc. And we collected the feces. We also did this study trying to understand which roosts were using bats to, to reproduce, to have the babies. And we did a project trying to understand how landscape affected bat activity. Madagascar is not so complex in terms of types of habitats. They have rice, in like water rice. They have rice in the mountain, and they have tiny forest and what we call secondary vegetation, which is the upcoming rice. Okay, so it's like a regrowth, but it's going to be rice. So basically, these 4 habitats. We use automatic bat detectors to control, to record bats using echolocation. And obviously, what it was expected, most of the molluscids were in the rice, specifically in the water rice. And we use genetics. We did the same in the Ebro Delta, and let's basically replicate everything in Madagascar. We use genetics. We found 2 important species in terms of rice production that affected by rice. One was like a similar borer, like damaging the plant, and the other one was damaging like the rice itself. But then other crop pests like sugarcane, macadamia, not really relevant for Madagascar, but we found them anyway. And obviously insect disease vectors, which that would give another talk. We also use the results because we wanted to replicate the same as in Ebro Delta, and we spoke a lot with farmers to understand their feelings, what they need, what's their opinion. We didn't want to be like these white people going to Madagascar and saying what has to be done, but we wanted to learn what they needed, if they needed anything, because maybe they don't, but they say yes, they needed some help in the agricultural lands, and which were their priorities and their difficulties. Basically, just to put you into context, 75% of the farmers did not have enough rice to cover their family needs in a year. 75%. So that means that 75%, 3 every 4 people did not have enough food. And when I say food, it's rice to finish to close the year. And that's a lot. 80% of the population is under 25 years old. So the pyramid in terms of population is like that. It's like you have a big base of really young people, like kids, and then very few people. These were the olders, these were the oldest people in the town. Overpopulation and needs for food, big problems. Well, that was like several expeditions in Madagascar. But in terms of simplification, that was the main result. And then we continued after a few years. I don't know if you know that this is a chironomid. That was another study back here at home. We started using similar techniques in pulse, which also have rice paddies. We tried to study if bats were actually following these so-called clouds of mosquitoes. Mosquitoes suddenly pops up and emerge with a big cloud, and then they disappear and they move. So we tried to understand if bats were actually looking for them and trying to take advantage of the abundance. And we use detectors again and feces again. That's our methodology, as you can see. We found out a huge effect by temperature and climatic conditions, and a very few little effect, significantly, but little effect following the mosquitoes. That's what we were expecting. But for me, the most interesting thing is that sideways, we detected chironomids in the diet. And chironomids are really important for rice as well. These are a larvae that swims on the mud. And when it swims on the mud, they release the seeds. So during I don't know how to say that in English, when the farmers throw the seeds on the mud for them to grow, during this first period, before it gets the roots on the land, if there is lots of chironomids swimming on the mud, they release the seeds until the surface, and then they die. So there's a big impact in terms of seeding seeding the rice paddies. And we didn't know that bats were feeding on these insects as well. Well, that's the chironomid, that's the kind of effects that have on the seeds when they try to make the roots on the ground, and they cannot. Again, we continued with the project, now back in Ebro Delta, again, with another student, Cecilia. Cecilia did a really nice job working on a different topic because she was working on acoustics, another project that I'm not going to explain you today, but sideways, because of genetics, we detected this, and this is an invasive species that came first from US, then from US infected China, I'm talking about decades ago, and from China passed to India, India to Greece, Greece to Italy, France, and we detected for the first time in the Iberian Peninsula. It's an invasive species, also damaging pest for rice, and we found the species analyzing the feces and looking for a genetic confirmation of the species of the bat. So we used metabarcoding, and we were not expecting something like that. We were not even paying attention. But when we checked the list of species, out of curiosity, okay, what did we find? And we found this species like, hey, wait a second. That's something important. We might inform the farmers, and that was very useful because we used all this data to inform land managers, the natural park, and everything else, just to keep an eye on the species. And that was not one single report because we detected it in 4 different regions in the delta, from one side to another. So it's probably spread. And reaching the end of this short story, COVID arrived. We had one PhD student that was supposed to work in Madagascar with a project that we got from National Geographic, but Madagascar closed the border for 2 years. That was dramatic. One of the worst management of the pandemic that I've ever seen. The levels of poverty increased a lot in the island. That was so harsh for local people, and we could not go into the island. So we got a ministry funding to get something similar, and we managed the opportunity to start the project of this student, Karma, in Spain, and we're now bringing it back to Madagascar now that the borders are open again. So I'm going to explain it very briefly. This is Karma. We moved to Huesca. I don't know if you knew that Huesca has lots of rice paddies. I didn't know that, but apparently there's many rice in Huesca, following the Ebro River. And basically, we took the advantage of studying this pest control in Huesca, because in the Ebro Delta, they use a lot of pheromones to control the pests nowadays. And in Huesca, because they have kind of more mosaic habitat, they cannot by law. And then we went there because the insect pests were far higher. So Karma had 2 main objectives in her PhD project. First one is to assess and quantify the effects. So we've been talking for decades that buds are helping farmers, and we always miss the key question, but it's okay, how much are they helping me? And all the farmers ask, even if they change the perception, they ask the value, always. So we wanted to put a number, how much money farmers are saving by having buds there. We wanted to know. And the second is, because we've been studying echolocation and also the insect pests, we wanted to study the effect of the echolocation on the reproductive behavior of the insects, which we suspected that was somehow related, okay? First of all, my dream come true. I replicated Boyle's study in rice paddies. So you remember the study that in corn I spoke in the beginning. So we did the same. We built this. This seems pretty small, but it's huge. So this is 5 meters high. It's far higher than 2 blocks, 2 floors. And we have like 20 by 20 square meters. It's not easy to build. We constructed 4 blocks of experimental studies, like the exclosures plus a control area nearby. And this is more or less how we build them. If it works, yeah, it works. A little bit quicker. But basically, we installed poles here, and then we start building them up with stairs, hanging this mist net, and get it ready in a minute. Yeah, okay. Seems easy, but it's not easy. It took weeks and months to build them up, and then it has to be resistant for the winds, to resist, storms. And Huesca is it's a windy place. I didn't know that as well. So this is how it looks when the rice paddies are full of water. We got this experimental, and here we have another one. I don't know if you can see it. It's quite impressive. I'm proud of it, to be honest. I think you can see it, but I'm proud of it. Then this is how it looks when the rice is already grown. It took 3 or 4 months for the whole process. And basically we had to go there and check that everything's fine. And also open it and close it because the farmer used a truck to go in and back for several treatments for pedicularia, for the fungi. So we had to build them big enough for a truck to go in and go on back several times during the whole season. And we couldn't put cables in between and not pegs below the water, because otherwise the wheels get pearls. Anyway, that's how it looks. Karma's proud of the result, and Karma's working hard. So we also replicated the thing, trying to find dead stems, infected stems, and quantify the loss of rice when bats are not around, and quantify. Again, I'm going to put some numbers and methods, but I don't want you to focus on this. Basically, we calculate with very simple models how much money and how much rice they were saving. That's an approximation. And that's kilos per hectare, something that can be easily understood. From very few kilos saved up until 100 kilos of rice saved by hectare. That's a nice number for me that we can use very easily to communicate the results. Obviously, the fork is big, but when you are talking with large areas, then you can calculate an average because it's going to have parcels and plots with a lot of savings and plots with not that many savings. So basically, this is how it works. Because we like to play with numbers, we calculate what's the maximum amount of rice that we can save if all the rice paddies in the Iberian Peninsula or in Spain, I think, yeah, in Spain, could be saved if they were all having bat boxes full of bats flying around. That's many. And the second part of the study was this study of the behavioral reproductive behavior change, and that's very impressive, even more than the other one. We capture the pests alive and we put them in captivity. Well, that's them playing. We put them in captivity in this kind of small boxes, much easier to build than the other one. We place some surface for them to put the eggs, which apparently they like a lot. And we built low-cost ultrasound broadcasters, like a playback. So we play back one full night from the same area we're doing the study. So we recorded one night, completely full spectrum, all the frequencies, and we reproduce them back under controlled situations. So we play back a normal night, and then we had like a silent night, like no sounds. And what we found is that this is the experimental, 5 control plots without sounds and 5 plots with ultrasounds. These are the eggs, very tiny eggs that we could find in the surfaces. Then we had to sex the insects afterwards because you cannot sex them beforehand. So basically you had to put the animals in the boxes, and as soon as they die, which is in 3 days, the cycle is very short, you can collect them and you can certify if it's a male or it's a female, and then ponderate your results by the amount of females that you actually had. That's how it looked on a laying, okay? And this is amazing. So in the control, so silent nights, they put so many, like twice as many eggs as in the treatment when we play back a normal night of sounds. So basically, this is like the ecologically speaking, it has a name. It's like they are afraid. I don't know how to say that, but the insects, they are afraid of the ultrasounds. So when they hear the ultrasound, they stop putting eggs. And the interesting thing is that the number of eggs are half, but the number of layings is the same. That seems that they stop putting the layings. They make shorter layings with less eggs each, but then same number of layings. So they try the same times to put the eggs, but maybe eventually there is a bat flying by, then they stop. They close and they start again. The total number of eggs is half, but the total number of layings is the same. And this was kind of the end of the story. We are now replicating this in Mexico, like the exclosure things, all the things with bat boxes, genetics. We have replicated that in India with a friend, and we're trying to do it in continental Africa as well. And just to close, I don't know what's the time now? Because I don't know. Oh, okay.
No, that doesn't work.
Yeah.
Okay.
10 to 1.
Okay, good. So I'm going to close my talk by explaining the last project I've been involved, well, the last that I want to speak about, and it's not a scientific project, it's a communication project. So we got funding from WWF to go to back to Madagascar and try to explain all the story that I have explained, or all the interactions between humans and bats in a nice way, using photographies, but most importantly, without any prejudice. So we had to erase everything from my brain, go back to Madagascar and try to document the whole situation without prejudices, without pre-information, as if I knew nothing about everything else. And that was an exercise, like bringing the experience to one of the first growers countries that I shared with Joan de la Maya, which probably some of you know. He's an amazing photographer, and I recommend you to check his photos, are like mind-blowing. And for me, it was an honor to be with him because it was a learning process for many weeks. So we went to Madagascar with this aim, try to report how bats and humans interact with no prejudice. And when we spoke about Madagascar to friends, family, and others and colleagues, many people think about rainforest, which is like what you find in travel books. But Madagascar is actually this. So when you land in Madagascar, even when you're approaching Tana with a plane, you can already see like huge and vast areas of extensive rice paddies. And obviously the methods that they use for planting are not the most updated nowadays. So they plant the rice seed by seed by hand. So they make a hole and throw the plant, all the plants. So they basically invest all their lives planting rice from sunset to sunrise, sunrise to sunset. And yeah, that's how it is. Sometimes in the most advanced places, they have like kids' schools for rice. They put all the rice, and as soon as they have tiny plants, they took them one by one and they plant them in the fields. Truly, that's an amazing job. And the thing is that they have huge losses of harvest, like some years up to 80% because of cyclones, pests, fungi, whatever. And because of that, and I didn't explain that before because I wanted you first to see the pictures. So their solution is, okay, we don't have enough rice because, all of these reasons. So we basically burn more forest. We fertilize the soil with the fire, and then we grow more rice. And that's the way how it's been doing for many years. And that's the reason why there's no forest left in the island, almost. This is one young guy we met, and he was very nice to show the fields, and he showed how they work, like daily. And that's more or less the result. Okay, all these pictures, some of these pictures are mine, some of the pictures are from Joan. Okay, these are like some of the direct results for endemic species. So they are the less mobile species just they die during the events, but some species they fly away. But even the more mobile ones like bats, if they don't have any other place to go, it's like a slow death. But anyway, the populations are declining, and most of the species are in very bad situation, and some of them are extinct already. So our project started here, one in Tana, and then we did a big transect across the whole island, trying to cover as much diversity as possible. Oopsie daisy. So the first thing we did is we landed in Tana, capital. It's like the biggest city in Madagascar. And the first night we went to a restaurant, we were looking obviously for that, and we found the bats in the menu. This is, here it is, Russet, which probably is not a Russet, it's a Pteropus, but anyway, everyone calls them Russet. And there is a big company hunting them, keeping them frozen, sending them away. But the problem here is that this restaurant is like the fancy restaurant. So who is consuming these animals? Tourists. So people that are coming from abroad comes there and they say, oh, I want to taste something typical, something from the region. Let's go and eat some bats. Okay, it's not local people. This is obviously a very fancy dish, and it's not probably the most common menu for local families. Then we moved, we took a car, we traveled up to Majanga, and then in Majanga, we were exploring things, asking people a lot. I discovered that to do a documentary and a photographic project, like seriously, you need to invest like 75% of the time asking and wandering around, and then very little time taking pictures. So we found a market where they were selling Pteropus. This was well, when we arrived, they say, no, it's over. We don't have more Pteropus anymore. And when we asked when they were going to have more again, They said, no, it's just in weeks. But we went back next day, and the box was full of theropus, and they were sold like in minutes. And next day we came back, and the box was full again, and they were sold like super quickly. So the thing is that they were replacing theropus daily. And that was the woman just selling them. They kept them alive in these boxes, but then it's like the same as we do here when we go and buy some rabbit. Exactly the same thing, but with bats. It's just similar thing. They cook them in several ways, but mostly in ovens or local frying. And we had the advantage of meeting this woman who very kindly offered us to join her at home and see how she cooked the animal, because we were asking, we were interacting with people a lot, and we say, oh, how do you cook the animal? And she said, okay, let's go home and I show you. And we obviously went her home. He offered us like a table to sit with her and her daughter, her mother, and everyone else, and we could join them like a normal weekend. And that what she explained to us is that they eat bats during the weekends. It was like a special meal for her, because normally it's chicken, but then to change a little bit during the weekend was bats. Then we met another woman on our way when we were going back to the south. We were just driving, and we stopped in this kind of road restaurants for truck drivers, same as here in the highway. And it's a small restaurant with plenty of options. This is like the aspect. Obviously, it's not the fancy one we visit in Tana. And this is the amount of food they prepare, because many people stop there. It's cheap restaurant, good food, traditional. I mean, the cooks are local people that know how to do the cooking. And many people love these restaurants in the road. It's like the cheapest option to eat something that's cool. And another person and character that we met, this is Philippe. Philippe is what we would call a bat hunter. He's been hunting bats since he was 17, and he hunted bats for self-consumption, and sometimes, very rarely, to exchange with some other food, fruits or whatever, specifically during the high season. If he hunts like 3 animals and he's going to cook one, he changed 2 of them. Okay. The funny thing here is I've been capturing bats for many years now, so 15 years now, or 17 years now. And when I saw Philippe hunting the bats, I could see straight away how good he was with handling. So he was not using gloves, he was not using anything. And it is like a 1.5 kilo animal with strong teeth, no single bite. So Philippe was extremely professional, not even professional. What he has in the hand, this is a mist net, but this is a mist net like a fishing net. It's so heavy. And the bats are usually fly above the canopy, really high, up to 30 meters high. This guy took a stone with the feet attached to a rope. He did like these cowboy things and throw the stone and hang a mist net up to 30 meters high in 5 minutes. I've been in my PhD in the Amazonian rainforest, where Albert just said before. I was using canopy nets, and it took me like 2 hours to send a net, and he did it in 5 minutes with a strong net. It's like very proficient. I could see it. So this is the Theropus species, declining species and endemic to Madagascar. I forgot to say that 80% of the bat species in Madagascar are endemic. So Madagascar has this peculiarity that most of the species are endemic. And then the end of the trip was in the south, in a dry forest full of cactus, baobabs, euphorbias, and we met Gaga. Gaga is another type of bat hunter. He lives in a small society, in a small community, maybe 20 people, like 4 adults, 16 kids. And he was living far away, isolated from anything. Just to reach his community, I had to walk, sleep in the middle of nowhere. There was no roads. And for me, it's the first time I met someone that didn't know how to use agriculture and animals. So it's like a hunter-gatherer. What we call that is the first time I've ever met someone that didn't know how to have chicken at home and plant some rice or something. So basically, the whole community consumed what they got from the forest. It was an extreme experience for me. So Gaga was hunting bats out of the caves. You can imagine a huge hole in the ground, like 100 meters of diameter, huge. And then the bats, when they emerge, they just start doing like these rounds, flying around and finding ways out to go to the forest. And that was one of the ways out. This is not natural. So this was kind of walls made by plants, dry plants that he put it here. And he basically waited there when the animals just emerge from the bottom part of the cave. They kick it with a stick and they hunt them. Same in the caves. They went out, they went inside the caves with fire. Then when the animal just flew away, afraid of the fire, they kick it with the stick and they hunt them. And we were also invited to the community. That's the whole community. And they explained to us that they use bats for normal food. And when they got like good meal, because it was not always, they join all the community and they sing and they tell stories and they share moments together. But that, for me, that was like a time travel. And, you know, it's just amazing. And this is back to Tana. When we were leaving, we stopped in Ranomafana and another national park. This is one of the common villages. As you can see, all traditional buildings, except for this, which was built by some random NGOs with the best of the intentions. And this building was full of bats in months. And this is the special character, Mormopterus. Colonies with thousands of animals. And as I said before, some people love them and some people hate them. So this is one of the people that love them. This is the councillor of the city, well, city of the town. And he collected already the feces to fertilize the fields. That's the first example that we found in Madagascar by local community of using the guano for fertilizing. He showed us how to fertilize, just basically throwing and spreading the guano on the fields. And then we started digging a little bit more with the guano business in the island, because Guanomat, I don't know if you've heard of it, it's all around Europe, but it exports guano from Madagascar, not using the most ethical methods. And we tried to visit people from Guanomat and caves exploited by Guanomat. That was impossible. So we met the people, but they lied to us. They brought us to other places, caves that they had no bats, something they didn't want to share the information. And then we discovered that there are actually 3 companies in Madagascar exploiting guano and sending guano to Europe, and they are competing a lot. There's a big business on that, but it's business for few people. And these people, we also discovered afterwards that they were into politics. So actually the director of Guanomat was presented as a potential president for Madagascar last year. So yeah, difficult story here in terms of Guanomat business. Something for next trip. And this is one of the caves that they say that's plenty of guano, and all of this is sand. Actually, it's not guano, but it looks similar. This is one of the most common species developing this pest control in Madagascar, and we obviously did some education activities as well with people, with kids in schools. And this photo, I want to highlight this. I know that some of you do photography as well. And you know that most of the pictures are kind of faked pictures. So the bat actually was photographed on a specific condition. The guy throwing the guano was because I asked him to throw the guano. This picture was natural 100%. So I was not even speaking to them. I was speaking with the professor outside. And when I went in, I found the exact situation. They were all laughing about this book, and I had nothing to do with this, 100%. And yeah, just to finish, a take-home message. Well, bats provide essential roles as pest control in rice paddies, but in many different crops. But most importantly, in terms of my first question today, can we use ecosystem services to promote conservation? My opinion, and I think I'm quite strong in this opinion, is like we can use ecosystem service as a first step, just to connect with people. As soon as we have the connection, we can start talking about landscape complexity, ecosystem stability, etc., etc. So for me, the ecosystem services per se, it's not a solution. It's not like the argument that you can use it to convince people, but it's just a first tiny step to make people see you with another eyes. And it's what I've I've heard in the Ebro Delta, I've seen in Madagascar, I've seen in Mexico, and then now in India and other places. It's like one tiny step, but it's so powerful that we need to use it, because otherwise, if you don't connect, you can explain whatever. Going back to the paper, scientific facts, even if they are robust and they are super scientific and super truth and is super perfect, if you don't connect with the people that are on the ground, what's the point? And obviously, country-specific context has to be taken into consideration. We can never be in Madagascar explaining, being like paternalist with our experience in Europe, or same in Mexico. You have to work close and side by side with local people and try to learn from them first of all, and then let's see how it goes. And obviously everything, so many people and institutions had joined this project for many years, and I will miss many, of course, many people. So thank you. I think I've over the time. Thank you.